Hello everyone, welcome to the channel. I hope everyone is doing good. So in today's video, we are going to discuss about the vector DB. We are also going to discuss about the vector libraries, what is the concept behind the vector DBs, and what was the demerit or what was their shortcomings in the relational database which led to the development of the vector DB. In the next video, we'll explore one of the vector DB and we'll try to understand how it can be integrated to our Gen AI pipeline. So before going into the vector DB, understanding of the vector DB, we should understand how the traditional queries or how the traditional search used to happen. And now also in most of the places, traditional search is being taking place. So in the traditional search, we have a database, inbuilt database, in which we have indexed object. We fire the query, and that query and indexed object create a matching. Like for example, in any of the search engine, if you write, what is the meaning of or where how is Canada in winter? What is the extreme temperature in Canada in winter? So that keyword will be matched with the indexed object, and as per the matching, that comparison is done, and after the comparison, you will get multiple answer. So in case if there is no direct keyword matching, in that case you will get weird kind of answer. And also if we give two different kind of sentences which have a same meaning but the words are different. For example, the story is fascinating. The second thing I can second line I can write, the story is interesting. From the semantic perspective, both the sentences, the meaning of both the sentences are same, but for the keyword matching, both the sentences will be taken as a different sentences. So in the traditional approach for the searching, if we give these two sentences, there will be a keyword matching and most probably your answer will be different in both the cases. But if we do the semantic comparison, if we understand the semantics of this line and then try to do the searching, in that case, we'll have a single answer for these two sentences. So now the question is, what is generative search? So generative search uses the capability of LLM to do the search on the basis of semantic. So your LLM capability is to understand the semantics of these two sentences or multiple sentences, and using that semantics intelligence, the searching is done on the in-text object or whatever algorithm it uses. So nowadays, when we search, we are using generative search. We are using the capabilities, or we are leveraging the capabilities of LLM in our searching. So in the traditional search, we were not using semantic knowledge, but in the generative search, we are using the semantic intelligence. So this is the basic difference on what we were doing the search earlier and now how the search engine are being performed nowadays. Now the keyword which I'm talking about is semantic understanding. So we should talk more about what is semantic understanding, and that will make us clear the actual problem statement. So what is semantic understanding? So semantic understanding means to understand the meaning of sentences. So it can be used for the text sentences. For example, I mentioned the story is fascinating, and the second sentence, the story is interesting. So both the meaning is more or less same. So we can use the semantic understanding on the text. For the images also, two similar images can have the same semantic understanding, and similarly with the audio case also, two separate audio having the same kind of meaning will come under the same semantic understanding. Now in two different sentences in which the semantic understanding is same, will have zero lexical overlap. Lexical means the word overlap, and very high semantic overlap means there will be overlap of the meaning and there will be no overlap of the word. Okay. And how does it do that? So it extract the meaning of data from these two sentences. So generative search, how it works, it extracts the meaning of these two sentences, and then it goes through the multiple indexing, multiple documentation, and try to get the near about meaning of that particular sentences. So before going into how actually generative search work, and how we use this data in our vector DB for a better searching pattern, we have to understand few terms. So one of the term is embedding. What is embedding? What is word embedding? Embedding means getting the meaning out of particular word and creating a vector out of it. So word embedding, I'll write it here. So what is word embedding? Word embedding, it's an NLP, natural language processing technique, that represent each word as a numerical vector in a multi-dimensional space, capturing their semantic and syntactic relationship. Means each word will be represented as a single vector in a multi-dimensional space, and which will give the information of the semantic and the syntactic relationship between the words. So this is the basic meaning of word embedding. So embedding means meaning of the word. So there can be word embedding, there can be sentence embedding. Sentence embedding means two sentences having the same semantic understanding. So when we store this data, like in a traditional database, what happens? We store in a rows and columns or in a XML format, JSON format. We have that data being stored there, not the meaning of the data being stored. But in embedding case, what we do, we read the word, we read the sentence, we create an embedding out of that word or a sentence, and that embedding will be represented as a vector in a multi-dimensional space. So vector database will help you to store this word embedding, to store this numerical vector in a multi-dimensional space, and each dimension will give one of the semantic meaning of that word. Because a particular word can have multiple semantic meaning, it can have a different relationship with a different word. So that will captured by multi-dimensional thing, and that is not possible in a relational database. That is only possible in a vector DB or in a vector library. So I have downloaded one vector embedding images from one of the website. So you can see here, I'll maximize the image. So these dots are the vector, means these are the embedding from the word. And you can see the similar kind of embedding will be in the same space. So this green color vector embedding, the meaning is non-fiction. So all the non-fiction novels or all the non-fiction books will be in the same space. So if any search is being done in one of the one of the vector in this space, then it will get all the relevant information near to this space. So if you search anything related to non-fiction book, so you will get all the answer related to non-fiction books. There will be no irrelevant search output. Similarly, if you see this blue color, it's a crime novel. So all the blue color will be in the same space. So when the word meaning is extracted, the embedding is created, that embedding is converted into a digital vector, and that vector is being stored in a multi-dimensional space, keeping in mind that all the similar kind of vector is stored together, and there is some different hierarchy to store. We'll discuss in later point of this video how this store process happens, what are the algorithm which runs in the background. So now we have one more topic, what is vector stores. So I'm trying to make it more relevant, like what happens behind the scene of a vector DB or a vector store. So initially it may look like a bit of confusing thing, but I started with a normal problem statement, the normal traditional search, differences with the genetic search. And from there, I'm trying to build the story, like what is the vector store, and why we need a vector store, why we need a word embedding, and how I goes into we go into the algorithm and try to build one understand what is a vector database. So I hope this story will be at the end of this video, it will be very much clear and you will know all the concepts behind it. I'm not going very deep into one of the any of the concept, but if you want anything very detailed in particular algorithm or something, you can ping me, you can post your comment, and then in the later video I can create more detail of it. But that is not required as an application developer. So this much of knowledge is enough to get started with a vector dealing. So now coming back to the topic, what is vector stores? So vector store, like when we I talked about the embedding. So now word embedding is not very straightforward. It's very complex. Getting all the embedding of a word of a sentence. So storing this embedding, retrieving this embedding, because when you store this embedding, you have to create an index and then store it. And then when you query, you write a kind of query, search engine, search query on this kind of embedding, that object need to be retrieved, and it should be done in a limited time. It should not take a very long time to retrieve the your object or retrieve your answer to this query. So this whole process is time consuming, and if we have a lot of information, if you have a lot of words, lot of information, sentences, then this vector embedding will become very difficult to handle. And for that we need a very specialized storing mechanism, retrieving mechanism, update mechanism, searching and filtration mechanism. And for that we have a vector stores. So vector DB is a part of a vector store. So vector store is a higher class hierarchy, and inside the vector store we have a vector library and vector DB. So if you don't understand what is vector store, just understand that vector store is similar to vector DB. So now vector store is something which will store all your embedding in a vector format. It will create a multi-dimensional space. It will help you to do the filtration and searching on that particular embedding on a list, on a set of embedding in a very fast way. So now how does this vector store works? So in very high level way, I'll try to make it clear. So I'll just remove this part. So first we have a raw data. Okay. So raw data can be in the form of documents. It can be form of images. It can be form of audio also. Then with the help of raw data and with the help of multiple algorithm, it creates or it understands the embeddings. So it creates a embedding models. This embedding with the now this embedding models contains the semantic nature or semantic meaning of your words, and this embedding is then converted into the digital vector, because we need to store into some system, a computer science system. So we need a vector embedding here. When it is when it gets converted into vector embedding, then it is now moved to a mechanism, a storage system where it can be stored in a proper way, and that we call it a vector database or a vector store. Okay, and there's a relationship between all this part. Okay. So this is very generic, a very high level understanding of how this vector store works. There's a raw data. You get the embeddings, means the meaning of that raw data. Then that embedding words or embedding model is converted into vector embedding, and there is a digital embedding. And this the vector embedding is stored into a multi-dimensional space, and that space is provided by the vector store. Now this vector store consists of various components that work together to provide efficient storage, indexing, querying capabilities for a high dimensional vectors. So there are few key features on which these vector data stores work. So I'll write it all. The first key feature of vector store is data management. So data management means the easy data storage. Data store can be done in easy way. Insertion can be done in easy way. Deletion, all the CRUD operation, CRUD operation, the insert, delete, update, and all this operation can be done in a more efficient way for this vector embedding, and that is one of the feature of a vector store, which is called uh, data management. The other is metadata storage. So metadata store is associated with each vector entry, like all the vector embedding which we have created, and that gets stored as a part of a metadata storage. There is also and filtration, or the filtering can be applied on this vector metadata storage. The other is ANN, and ANN, the full form is the approximate nearest neighbor. So this is one of the search algorithm. You can call it a search algorithm. So once your data or your vector embedding is stored into one of the vector store or vector database, so with the help of ANN, one of the multiple algorithms. So ANN is one of the search algorithm, approximate nearest neighbor. So by the name only, you can understand that it gets all the information near to that particular word or particular embedding. So it uses combination of algorithm to optimize similarity search, such as hashing, quantization, or the graph-based search. So ANN can be implemented by multiple way with the help of hierarchy-based, by with the help of graph-based. So this is one of the algorithm, and ANN is very popular algorithm because the computation cost is less as compared to other algorithm. We'll talk about the other algorithm also. So ANN, the searching algorithm, is searching the data which is already stored in a vector DB. But before searching the data, we need to store the vector embedding into a vector store, and that is done with a different algorithm, but by different indexing strategies. So what happens in a vector store? It breaks down a document or a website into a smaller segment and convert this segment into vector. So as we have seen here, this raw data. So this raw data can be considered as document or multiple websites. Now this data is being stored, divided or broken into a smaller segment, and this segment is converted into vector. Second is indexing process maps the vector to a data structure that can be traversed quickly. So once this vector embedding is created, so the storage of this vector embedding is done in such a way, in such a better data structure way, so that when you apply any search algorithm on this vector DB or on this vector embedding, which is stored in a multidimensional format, can be done quickly. And for this, there are multiple indexing process in a vector database. The multiple indexing process which is or multiple indexing process which is available in a vector database is, I'll write it here. The first is IVF. IVF stands for inverted file index. The second is PQ. PQ means product quantization. And the third is the way of nearest neighbor. So this is also one of the like this is ANN algorithm is used for a search algorithm also and for the indexing purpose also. So ANN. So this is good for high dimensional vector store. Okay. So these are the three different indexing process which is being used. The most popular is ANN is being used for storing the or indexing the vector embedding into the multi dimensional vector store. So there is one more algorithm called KNN. KNN means K nearest neighbor. We write it like this. So K nearest neighbor. So it is good for indexing process, for searching process. But and how it does, it calculates the distances between two different vectors, and the most efficient distance result is being given out. But in that process, much of the computation energy is being given into it. The computation cost is too much in KNN. So we prefer ANN process. ANN is far better, and it gives a kind of good kind of search also, and it also have a less computation cost. You will get more of the accuracy in KNN and less of the accuracy in ANN, but the computation cost is too high for KNN as compared to ANN. So ANN algorithm sacrifice is done on the accuracy, and it is very popular recently. How it does it does the lookup in a very fast way, ANN, and the time complexity of ANN is O log n. So if we talk about the time complexity, O log of n, and in this case in the KNN we have the, just a second, we have the time complexity of O(n). So searching time or the time to return the result is very less in ANN as compared to KNN. But one thing we should understand, KNN has a very big advantage of giving the accurate answer. Now we have narrowed down that ANN is very advantage in most of our use cases. So now ANN is one of the algorithm, but there are different ways to implement this ANN. Multiple strategies that has been developed for ANN. So that strategies are as follows. I will write it here. The first is tree based. Okay, tree based means hierarchy based, and one of the ANN algorithm strategies for tree based has been which is created is NO. So NI, I think it's being used by Spotify search. I will clarify in the later part of this video. So one of the strategies for ANN is tree based. NI is one of the product of that. Then we have a graph based. This is very popular nowadays. This graph based implementation of ANN search. And this we use HNSW. So the full form is hierarchical and navigable small word. I'll write it here. I'm not sure that which company is using this one. For a cluster base, there is something called cluster based implementation or cluster based strategies for the ANN is FAISS. This is Facebook AI similarity search. This is basically not a vector store or vector database. This is basically a vector library. We'll discuss later in this video the what is vector library, what is vector database. That comes both this comes under a vector store. So this is Facebook AI similarity search. So Facebook uses this kind of search. There is another cluster base which we call as PQ, product quantization. Then there is one more way of implementing ANN is hash based. So LSS is one of the product. Locality, sensitivity, hash. Sensitive hash. So these are the different ways how this ANN algorithm has been implemented or the strategy has been built on that ANN. We'll discuss few things about hierarchy thing HNSW, the graph base, because I told that this is very popular nowadays. So we'll discuss how indexing is being done, how this vector is being stored in a vector store in with this format. Okay. So this is the hierarchical way. So in this, what happens? We have a node and the edge. So when we have created the vector embedding, when we have created the embedding out of the word, then we create the vector embedding, which needs to be stored in a vector store or a vector DB. And for that, we'll have nodes and edges. So each node will represent data point, and each edges will represent the connection with the nearest point. Okay. So the algorithm will start creating a set of node and each will have a small number of vectors. So the how this algorithm will work, it will start creating, I'll just, it will start creating a the node, a set of node. Like for example, one node is this. Okay. Then we have another node here. Okay. And inside this node, you will have multiple vectors. Inside this node, we will have multiple vectors. I don't have any sign to create it. So, okay. Okay. This round shape is a node, and inside the node, we have multiple vectors. Now, the nodes are clustered together randomly. So like there are three nodes. So randomly two or three clusters are created. There will be multiple nodes, and with the help of multiple node, multiple cluster will be created. Inside each node, you have multiple vectors. Now each cluster will be considered as a node. So now you understand one thing. If you have very huge document, huge set of data, so there will be multiple nodes for that, and it will be very difficult to traverse through that node, understand that node. So it creates a cluster. In a cluster, there will be multiple nodes. Inside each node, there will be multiple vectors, and one cluster will be considered as a single node. So now the node becomes the combination of multiple nodes. Inside, we have multiple vectors. So this way, it creates the nodes. So the algorithm examines the vector of each node and draws the edges between the node and the nodes that have the most similar vector in that line. So for creating the edges, it understands the meaning of that vector, and to other cluster vector, it understands the meaning and try to create the edges with two vector or two different cluster which have a more or less similar meaning or very near to meaning. So this is how HNSW hierarchy navigable small word works. Now, storing this in a hierarchical way is very convenient for the query search also, because when you write the query to get the meaning or get the object out of this vector DB or vector store, So traversing will be very good. Like you can traverse by looking into the meaning, hopping through a different cluster, inside the cluster hopping to a different node. So and different vectors that can be done easily. So this way is very popular nowadays, and it is giving a very good result. So now we want to talk about the vector library. So there is two things. Vector library. There are three things. One is vector. What do you call? One is vector store, vector library, and vector DB. So I'll create all this diagram here. So vector store is the bigger in the hierarchy. So vector DB, means vector DB and vector libraries are the two classes of the vector store. So vector library stores the vector embedding in memory index in order to perform the similarity search. The search will happen the way like the similarity search means the similar kind of meaning will be fetched. But in vector library, it happens in memory. It doesn't happen in the persistent storage. Second thing is it is used for a small set of data. It is used for a kind of POC or some small set of data, not for a production environment. The bigger thing is in vector library, your searching will be fast because it is happening in memory, but it stores only the immutable object. Means the particular node, the information of that node which is being captured in vector library will not be changed. So it's a immutable. So everything what is stored in this way, index data, is immutable, and so it is not recommended for any big application or very scalable application, because in a big or scalable application, your data will keep changing. Or in a real time searching, real time indexing mechanism, your data will keep changing, and in that kind of that scenario, vector library is not preferred. But one of the very popular vector library which is available is FAISS for the Facebook. This one, and also NI, as I have mentioned, NI, which is also a vector library which is used in Spotify. But these are for the small set of data for the searching. These are not used for any data which is getting changed. For the Google also, there is one of the vector library which is scan, SCANN, SAN, it pronounced like S is silent there. But a vector DB, you can store the data persistent. You can create the insert the data. You can delete the data. You can update the data. It's not immutable. It's mutable. Real time searching can also happen there. Okay, but vector library is much faster as compared to vector DB. Now we have to understand where we have to use vector DB. So vector DB is used where we want a efficient similar search, where the information retrieval is required, where the question answer system is based. For example, you are asking a question, then you are getting an answer. Then again you are asking on top of that another question, you are getting an answer. So there must be a set of vector DB which is being stored. So their vector DB is very good in a chatbot. In a generative search, vector DB is useful. Then where we'll use vector library, where vector library will be used where we need a very fast searching, but the data is not going to change. That information, if it is getting changed, that will be not captured in a vector library. So now we need to learn about the, I'll just delete all this thing. We need to learn about the vector database. So now these vector stores become vector database or vector DB. So there are very popular vector DB in the market. One is ChromaDB, DB, Redis, Pinecone. So Chroma is open source. Chroma and Pinecone is designed for the small to medium size data set. Chroma is very much popular for the POC for a small set of production data. So in the coming videos, we'll learn practically more about the ChromaDB. So till now, you would have understood why we need vector DB. Why we are not going with our traditional approach or a NoSQL database approach. What was the reason for the invention or for the exploration of the vector DB? Now in the next video, we'll try to explore one of the vector database, which is ChromaDB, and we'll look into some of the practical things. We'll try to create something practical in the ChromaDB so that our whole lecture of the vector database or a vector store will be completed. I will not say vector database. We are not covering only the vector database. We have also covered vector store, because vector store is a higher class in which the vector library and vector database both comes in a picture. I hope you will be able to understand this video. If you have any doubt, any more detail you need, you can directly ping me, you can mail me, or you can post your question in the comment.